Example 17. Water at 20 degrees Celsius with kinematic viscosity 1 times 10 to the negative 6 square meter per second flows through a 25 meter long, 75 millimeter diameter commercial steel pipe with absolute roughness of 0.046 mm that contains the following fittings. One open valve with loss coefficient 10, one short radius elbow, loss coefficient 0.9, and one 90-degree bend with a radius of curvature of 600 mm. The length of the bend is not included in the 25-meter length of pipe. The entrance is re-entrant with loss coefficient at entrance of 0.8. And remember this, for re-entrant, it may not be given in the succeeding problems, but if not given, assume 0.8. And the discharge is submerged. Find the total head loss if the velocity is 1.8 meters per second. So we need the table for determining the K of loss coefficient of the bend. So R over D ratio is to be computed. Radius of curvature 600, diameter of pipe 75 mm. So it is 8, therefore the K of the bend is 0.28. So the head loss, the length is 25 meters plus the length of the bend portion, which is radius of curvature 0.6 meter times 90 degree or pi over 2 radians. Radius times central angle, remember. So 25.94 meters. The head loss therefore consists of friction plus entrance, loss coefficient at entrance, loss coefficient in head loss due to valve, then elbow 0.9, K of bend, which we have just computed 0.28 and from this table, and at submerged exit, which is this is equal to 1 of the velocity head. So for friction factor, we need to assume first that the pipe is smooth, and let's compute the thickness of viscous sublayer later. So Reynolds number, diameter, mean velocity over kinematic viscosity, diameter 0.075, mean velocity 1.8 over 1 times 10 to the negative 6, 135,000. Colebrook equation for smooth pipes, 1 over square root of F equals 2 log of Reynolds number square root of F over 2.51. So from this equation, we can estimate F 0.01691. And let's compute thickness of viscous sublayer to check if the assumption that the pipe is smooth is correct or not. So 14.14 diameter over Reynolds number square root of F. Substitute 14.14 times 75 mm over 135,000 square root of 0.01691. So the thickness of viscous sublayer is 0.06041 mm, which is greater than 0.046 mm. Therefore, our assumption that the pipe is smooth is correct. Therefore, friction factor is 0.01691. Substitute here. So 0.01691 times length 25.94 over diameter 0.075 plus loss coefficient at entrance, reentrant 0.8, globe valve 10. This is for elbow, this is for the bend, and this is for submerged exit. So, or discharge, submerged discharge or submerged exit. Then velocity head 1.8 square over 19.62. So the total head loss can now be computed 3.109 meters.